There we go. Hey, welcome to episode 159 of Quarkus Insights. And yeah, this is a special episode. Well, first of all, we don't know how many is around because it's Easter week. But we had Christian last week talk about Hibernate 6.4, and one of the areas he was up to talk about, or sorry, didn't cover, was some of the new features around vector search. And yeah, so let's just keep it simple. I'm not sure simple, but Christian, I'll give it to you, and then yeah, we'll talk. We'll see how it goes. So
Thanks, Max. So, hi everyone. Today I'm going to talk about vector similarity search with LangChain4j and Hibernate ORM 6.4. So, small introduction. I'm Christian, living in Vienna, Austria, and Bonn, Germany, and like to play tennis, go for a run from time to time. I'm the founder of PlaceBit and creator of Place Persistence and working for Red Hat since 2020. And before that, I've been a long time community contributor for Hibernate. So let's dive right in. What is vector similarity search? I try to draw a diagram here. And in essence, you have an AI, and this AI is capable of creating so-called embeddings. And an embedding is a vector. I will explain in a second what that is. But the idea is that for some data that you have, you're going to take that vector and put that into a vector store. And later on, when you want to query, when you want to find something, you let the AI process that query again and produce another vector. And with these vectors, you can then do a vector similarity search through nearest neighbor search to find similar or related data. Now, the vector itself is a numeric array of some dimensionality, and the numeric type is, the precision can be different. Of course, people try to use smaller precisions now because smaller precisions means less memory bandwidth needed on certain use cases, which allows for faster training. But yeah, just wanted to mention that there are different precisions. And to speed up the querying itself, there are search indexes. And there's roughly two different ones. I know I'm very coarse-grained here, but like the most important ones that are implemented by databases, as far as I know, are flat. There's this inverted file flat sort of nearest neighbor search algorithm, which is deterministic. That means that it will always produce, or it should always produce, the same answer regardless of what state your index is in. And then there is a graph-based, which is approximate, and the most notable one there is the hierarchical navigable small world algorithm. It's a mouthful. And I will not go into detail into how these algorithms work or how the index structure looks like. You can read up on that on the internet. But like these are the most important ones, and we'll see how these work. So what can you use vector similarity search for? That's a common question. And there's this, the common answer is like fraud detection or semantic search recommendation systems, but also image search. So there are AIs that can produce embeddings or vectors for images, and then you can find similar images or parts of the image potentially that are coming from an existing database of known vectors. Content filtering. So you could have, say, for example, a list of bad topics or bad words, and you produce these vectors, and then when you get some content, you try to find the similarities between those vectors, and if there is a intersection, if the similarity is big enough, then you could reasonably assume that the content is potentially bad. And yeah, So you can imagine probably for all of these searches that it has something to do with similarity or relatedness. So yeah, that's also the use case that I'm going to present. And for the supported databases, right now we have PG vector support, so Postgres only at this point in time. Although I've been in a meeting with Oracle people, and the folks from Oracle said that they're working on AI capabilities, and they would like for Hibernate to support these capabilities as well.
Of course.
Of course, yeah.
On both counts.
And they even said that they would like to help us or potentially even provide some of the implementations or mappings for that in Hibernate. And if any of you in the community have ideas for other databases or extensions that we should support, please tell us about that. We only knew about PG Vector and thought it was useful enough to even add support for vector similarity search in the first place. So any new extension, if it pops up, let us know. We will try to implement support for that. And as a small remarker, we could potentially implement all of these functions for any database with array support, because the different functions are somewhat easy to compute. So you can do the distance check between vectors with a simple query, but it's quite slow actually, because it will iterate through all of the vectors of all the rows and will try to compute that distance. So it's very slow without indices. That's why we didn't bother to do it so far, though know that it's possible. And with that, I will switch to my demo, and this time with the font size, the proper.
We try and improve every show.
Yeah, exactly. So I wanted to show first of all the build file here, because one thing you have to note is that you will have to use the Hibernate vector module if you want to use that feature. So this module will provide support for the DDL types, and it will register functions, and which functions we will see in a second. But in addition to that, that AI block that I've shown before, which will produce that embedding, you'll also have to talk to that AI somehow. And I'm using.
Christian, so the Hibernate vector is a standalone. Is it like a type library, or it works with older versions of Hibernate, or how does it work?
Oh, sorry. Yeah. So the Hibernate vector module is like Nverse, for example. So it's released with every new version of Hibernate core. And so the expectation is that you will have to have aligned versions between Hibernate vector and Hibernate core. But so it's like a type library or function library, and it will integrate based on, or the idea is that it will integrate based on the dialect that is chosen. So for now, if PostgreSQL is detected, it will register the functions and types, and in the future, for Oracle, we will do something similar.
Yeah, it's just because if this is a 6.4 version, I was just wondering how it works, because in Quarkus we have 6.3 of Hibernate at the moment.
No, you have 6.4.
Sorry, that's 6.5. Yes. I'm behind.
We just released ORM 6.5. Yeah.
Yes. Sorry. Yeah.
Or actually, it was the 6.5 candidate release number 1.
Yes.
And that kind of half answers my question about whether, if you're using Quarkus, you'd have to work backwards from the Quarkus version that you're using to what Hibernate version Quarkus is using, and then feed that into your POM or your Gradle file.
Right. Yeah. I don't know. Maybe the platform POM could mention that Hibernate vector module, so you don't have to mention the version explicitly.
Yeah,
we could for sure. Yeah,
maybe that's an improvement that we could do in a fixed version.
Yeah.
Right, but that's the idea. So you add that module, and then you also add that module for LangChain4j, and I'm using Olama because even though OpenAI is very prominent in the news, I do not like paying dollars for a demo. So That's why I'm using this one here, but it works quite well. So when I first tried it, I was quite surprised to see it work immediately.
And just to give context here, so LangChain4j is a library that talks to different, a very set of large language models like Llama, OpenAI, OpenShift AI, Azure AI. I don't know. The list goes on. But I assume here for Llama, you're using the ones where it runs locally, so you can have local models.
Yes, exactly.
And then, by the way, for those who don't like Quarkus LangChain, we're actually gonna have an update in the coming weeks, because we had an episode like 2 months ago about Quarkus LangChain, but there'll be an update soon on what's changed there, because every day is new in the
in AI. 2 months is like 10 years.
So we'll have our 5-year update in a few weeks. Yeah. But yeah, no. So that's the cool thing, is like you're using Quarkus LangChain against a local running model, right? Yeah.
Exactly. Yeah. Cool. All right, and I even tried that on my laptop, and it even works there. So don't be scared that you will require a big GPU. Maybe it's not that fast, but I don't know. Maybe response times of a second or so at max.
Yeah.
And are you going to be doing like streaming plus the model now, like right now?
I'm sorry, I don't understand.
Sorry. So are you about to continue streaming while also running the model locally? Or have you got another?
We can do that in a few seconds, yeah. So,
it sounds kind of scary.
No, it's actually quite fast. So let me show you what I did here. So first of all,
remember, Holly, it's not like Graal VM that is both CPU and I/O. This is literally just CPU and
Yeah, although I always found if I did anything when I was streaming, it stopped working. But maybe that was just my laptop.
Yeah, maybe. Well, here's usually the LLM configuration, large language model configuration, but I don't have any because I'm using, where is it? Oh, actually, I moved that to the resource. I wanted it to be slick. So I'm using this embedding model here, and the embedding model that I'm using is the text. I don't know what it's called exactly. I can look it up later. But it's a text embedding model. I think there's only one or two on Ollama. And, I'm just taking that text and I was trying to prepare that content somehow in a more or less structured form. And, create the embedding essentially. And then here comes the vector. So the vector is a float array. And what I am processing here is an article. I decided to process articles of our blog in relation to, so it's in.relation.to the Hibernate ORM blog, the Hibernate project blog. We publish posts about other Hibernate projects there as well, not just ORM. And we can, in a few minutes, maybe run that processing from scratch, but for demo purposes, because last time the demo gods have failed me, this time I have prepared everything so that nothing goes wrong. We have the URL or URI, the title, the author of a blog post or article, the content, and then the embedding. And what is interesting here is that the text embedding says that the result vector will have a dimensionality of 668. And you can configure that. So the two things that you have to do when you want to use this Hibernate Vectors module is you have to use the JDBC typecode annotation to say, hey, this is a vector, and you also have to give it the size. But apart from that, this is just a float array.
I'm just curious. That SQL type is what type? The SQL type. Which package is that one in? Oh, Hibernate. Okay, got it. Okay.
Org Hibernate type. So it's that Java SQL types class, which is like a class of constants. And so this is an extension to that. We even copied all of the existing constants, as you can see here,
Yeah.
for making it easier for people to just switch, but it also adds new codes. So you can see here the code 10,000. And that's something that I maybe said in a past Quarkus Insights podcast, that this is something that we changed in Hibernate ORM 6. We were restricted down to the JDBC types, and there were quite a few problems with the potential JDBC integrations for more advanced types that are now resolved by us taking advantage of this integer range and just adding new types to model these more advanced things. Right, so this is how you define the embedding. Let me show you what the table structure looks like, because I believe it's printed out here. I hope you can see that. I guess you can, it's big enough. You see here the embedding column has the type vector with the size 768. And I mean, this is just a DDL for creation, but what is interesting is that the import SQL that I have here also imports something into this articles table. So I pre-imported some articles, though I have a scanner using the Java 17, or was it Java 17? The HTTP library of Java, the new one, to grab all the contents. And at the end, you can see, all of these float values here. So this is an array. I pre-generated the embeddings, but we can generate the embeddings later on as well. I have the unprocessed data here commented out. And then we're going to create an index on the articles table using the hierarchical navigable searchable world.
Just follow here. Like right now, your import SQL here has computed vector values, so you don't have to run the processing on every startup, right?
Right. Yeah. Also that, but we can run it later on. It's no problem. I can show you it works, and you can also try that by yourself. So this is a public GitHub repository.
Sure.
But so we're creating this index here, and we're saying on this embedding column we want to use this special vector L2 ops. So this means that when we're using the L2 distance function, so checking the distance between two vectors, then it will make use of this, or it can make use of this index. And then there is some configurations here that are specific to the algorithm that is used, this HNSW. Since it's an approximate index or approximate algorithm, you have to configure what is the tolerance that you're okay with, or what is I think it's called the recall rate, that means how often does it or should the index be considered from different vector points, so to say. I don't know the exact details. It just works. It just makes it fast. But so this is my base data. And let's see, we have the article repository here to find articles. And one of the interesting things here is the get similar articles function. And I think I have, so Swagger UI to find similar articles here. So this is a post. And here we can say which function we want to use, L1, L2, or cosine, and the distance between similar articles. So let's look at the query first. Query is quite simple. We're just using article A1 in the from clause. We join it against itself, and to avoid duplicates, we say that the A1 ID has to be greater than A2 ID, to avoid having both articles on the opposite sides being part of the result as well. And then we're just using that function, and here we have L1, L2, and cosine, So it's either L1, L2, or cosine distance of A1 embedding and A2 embedding. And this has to be smaller than a certain threshold. So a value close to 0 means that these embeddings are very similar. So since it's a distance, shorter distance means near to each other. And then we just create the similar articles DTO here to understand which URLs these are similar, and also the similarity as a result. So let's try that out and see what query we're getting. So if we execute with L2, we will see that there is this in relation to blog post about Hibernate Reactive version 2.2.2, and then there's another post about version 2.0.4. And as you can imagine, release announcements are going to be very similar. So that's why the similarity is very low, or the distance between the vectors is very low. And then we go on with a few other release announcements. We can even increase that to, let's say, 8. Let's see how many we get here. And you can see there is more release announcements. Of course, sometimes release announcements contain, featured features, so to say. So they're explaining what is new. So they could differ from time to time. So say major releases here or there could be very similar or not.
So I know you're going to go into LangChain in a few minutes, but this basically means that you could use this as I'm not even sure it's called this a poor man Elasticsearch, but it's similar, right? Like you can, sorry, it's like a Lucene index. You can use it to, any kind of closeness calculation. Like at this point, there's no LLM involved, right? It's just pure PG vector doing. Oh, sorry, you did. Wait.
What's the question next?
Yeah. This was just using the PG vector function in Hibernate, right?
Yeah, I can show you that. So let's look at the query. So we've been running this query here. I've been showing the HQL query version up here.
Yeah.
This is the SQL that is being executed.
Yes.
So for PG vector, there's this special distance operator.
Yes.
There's actually 3 operators, but this one here is for the L2 distance.
Yeah.
And this is also the operator that we provided an index for. So queries will be very fast.
Yeah.
Well, we're checking if the distance between the embeddings is below a certain threshold, and then we're just ordering by that similarity to find the most similar ones.
Yes. Yeah.
And this is all on the relational database side, so all in your PostgreSQL database.
Yes.
And hopefully soon also in Oracle. So you can use that on your enterprise application to find similar content, for example.
Yeah. Right. Yeah. So you use the generation of the embeddings is the magic parts, and then you use the feature in the database just to. At that point, there's nothing AI involved or LLM involved. Is what I'm saying. Yeah.
Right. I mean, this is just vector search.
Yeah.
Vector search itself is not tied to AI by any means, but it's often being mentioned in that.
My bad attempt of trying to indicate that this is useful for other cases than just pure AI or LLM.
Of course, indeed.
It's useful outside too.
It is, yeah. Although, I mean, getting to these vectors is, I suppose, quite a complex task. That's why you're using an AI specialized to do that. Right. I mean, we can also. So first of all, we can see that with higher thresholds, the similarities might become not so good anymore. So it's very domain specific to understand what sort of threshold you will have to use.
Yeah.
And also the functions have different values. So L2 was like mostly below 10, whereas L1 is, I don't know, I think like around 100. Yeah, right. So the most similar articles are, again, we can compare that with L2 as well, but these two articles are the same for L1 and L2, the most similar ones. But the values are drastically different. And the cosine distance is, I don't know where it is. Maybe that will take too long. Right, that fetched just all of the data, I think. So it's in the sub-zero values. Let's take, I don't know, 0, 1, 5. Okay, 0, 2 maybe. There you have it. Okay, and if we look at the queries, so you can see there is a different function being used now called L1 distance for the first, for the L1 kind of request that we did. And for the cosine distance, there is this special operator here. All right, so this is what's happening behind the scenes. And that's the similarity part. Let's try to import articles. Let me just quickly disable my importing of the data. And instead, I'm going to import data without the embeddings. And then I'm gonna just process. Before I do that, I'll clear the console so you can see it being processed. So here you can see I'm running a query that will try to find the unprocessed articles. So it's checking for embedding is null, and it fetches the first 10 rows. And then it will continuously call update to set the vectors on the rows. And here you can see the vectors that are being bound. And these vectors are being generated as we speak. So if we look at the article resource once more, which is where we have this post process articles method. So here you can see we're just finding the unprocessed articles, and then we're computing the embedding, and the embedding just goes to the embedding model, taking all of that content, the title, the author, the content of the article, concatenates it to a single string and asks for the embedding, and just takes that, saves it. That's it. And we can, continue to execute here until there is no more articles being processed, and we will end up with the same results. And as I said, this is on GitHub, so you can play around with it. You can, try to import a different website and, just see how well it performs. And as you can see, sometimes it takes a bit longer, and now it's immediately finished because there's no more unprocessed articles. So we've reached the end. And that's about it, I think. Let's get back to the presentation. So what are the pros and cons of this? It improves search relevance magically. So this is sort of a pro. Especially because it's easy to implement. You just have to add one column, the vector column, add an index, and fill that somehow. And then all of a sudden you can search across a wide range of data by simply doing this vector similarity search. So it's very easy, and I suppose also efficient, because it's just this one index lookup. Whereas if you have data spread across multiple subtables, if you have to join them to filter and find the correct data, then this might involve, more complex query plans for the database to compute. But on the other hand, this AI and the embedding vectors, these are black boxes essentially. You cannot make sense 768 integer numeric values, right? You don't know what that means.
Yeah, good luck debugging that.
Exactly. And, for data preparation, I have read into that topic a bit, and apparently that's a thing. So you have to play around with that. And that's usually trial and error to understand how to prepare the data, how to cleanse it, to get it to a state where the embeddings are actually very useful to you. Luckily, for me, it was no problem. So I just took that simple approach of, labeling it with colon, having the name of the field on the left-hand side, and it just magically worked. But then there's also the infrastructure cost of running Olama. Like, I don't know how much compute it will take. I think inference is not that hard on the CPU cost. But I think if you're, making your product search be based on that, then you might have to run hundreds or thousands of queries, which you will have to think about the infrastructure cost. And with that, I am finished. Q&A, please. Give me your questions.
So that was a half an hour, so that I won.
Oh, you won. Okay.
No, it's good.
Yeah, really interesting.
Yeah, well, we didn't get that much questions on it, but I really liked it because it shows, that we added this whole thing. Like, AI is awesome, but it's built on stuff that exists in different places and now just being used in a different way. So that's we got one here. That's a very not to this one, but it's a Hibernate question. Stupendios follows 65. Is there any way to get full execute SQL with parameters locked inside the query, not separately? And why would we use P6
I would like that as well.
Didn't we have that at some point?
No, we don't have that. There is a feature request. I think I created it, but I didn't get to implementing it actually. But yeah, I agree. It would be very nice to see the values inlined. Although you have to be very careful if you're trying to debug, or if you're trying to ask the database for query plans with explain, then using literal or like inline values is going to give you wrong results potentially, because if the database knows ahead of time the values that it's going to filter about, then it can optimize for that. Whereas with normal queries, where you use parameter markers, the database, or let's say PostgreSQL, for example, after the fifth execution of that prepared statement, it will switch to a generic query plan, which will then not optimize anymore for the individual values, and then you will have to figure out if that query plan is still optimal for your use case or not. So you also have to
But that's it.
Juggle if you want to inline or not.
But oh, sorry. Like, he's asking for just the log statements having the stuff inline. You're talking about taking that query and executing it.
I understand. I'm just saying that the use cases I had in the past were to figure out for easier query optimization, and I can tell you that there is a pitfall. Just be aware of that.
So because I can see Eric is saying you could actually use OTel and Jaeger with the open telemetry database. I haven't tried that actually. If that does it, where we merge them, it might be. But anyway, So if Eric is right, then that's the way to do. But yeah, I feel like but this is 10 years ago. I feel like we wrote something that did it, but I also remember there was a lot of discussion if we should include it or not. Because it's not going to be cheap.
Exactly.
Yeah. Okay, so that's cool. But yeah, and then we had some more generic ones. Those also Savanna's if where can you see Quarkus Insights? So yeah, if you go to Quarkus IO Insights, you will see the planned, the ones we already have like dates and stuff set for. And there is a GitHub repository called Quarkus IO Quarkus Insights, where we actually have issues for everything that is being proposed. So if anyone wants to have a talk or something, go vote some of those up or create new issues. And I see, for example, Douglas here was like, can you guys do a live session for general QA? So we actually have one planned. We just didn't know when and where and if there's interest. So now there's at least one person who likes it. So
cool. So then we should update, because I said to go raise an issue for that. But it sounds like there's there is an issue, and you should upvote the issue rather than making a new one.
But no, we did like what we've done in the past. Normally when we've done a release of a significance, we've done a QA session kind of thing. But last week or 2 weeks ago, we did the 3.8 release as a Brady bunch of like 9 people that was doing different things. But we actually had should we do a QA, which we've done it once a year, and we just haven't done one for 2024 yet. Well, there'll be one. And just an encouragement to everyone, if you want to have a specific session or want to come up and talk, that's fine. That's welcome too. Just open issues in that Quarkus Insights repository. That's the best way. Otherwise, just ask us here on live, and that'll be good.
Yeah, it's worth saying as well, though. Like, I think the general Q&A one is really good, and we will do one. But if you have like a specific technical question and you wait for us to do the Quarkus Insights, you could be waiting quite a while if we do one once a year. So there are definitely other places that you can get answers as well. So we have a Zulip chat, and so you can use that. Stack Overflow is a good place. You can also raise issues on GitHub for if something doesn't seem to be working, or if you've got a feature request, and then we can have a discussion on that issue.
Yeah, exactly. And then I saw Douglas had a specific question, which I can answer now. He says, Quarkus has started supporting JavaFX. How can we get Grail and native combined with Quarkus app using JavaFX extension, not necessarily requiring the glue on Maven plugin? So lots of stuff in here. So first of all, Quarkus itself does not. It's not like we are supporting JavaFX for everything, but what we do have is a Quarkus extension that lets you use the Quarkus framework in JavaFX. Right. So this JavaFX has all this visual stuff, and it has a rudimentary dependency injection, and there are different variations for like Micronaut and Spring and others. So what we've done is, or not we, a contributor, I forgot his name now, but there's been multiple attempts of doing that who succeeded just before Christmas, I think, on getting something working, and it's actually very simple. So now you can actually use Quarkus within a JavaFX app, so the Quarkus framework. This does not automatically mean that you're going to have native compilation for JavaFX. I haven't even tried to attempt that. I have used the JavaFX thing, and we probably could do a session on it. But not requiring the glue-on Maven plugin. Well, I don't think you need the glue-on Maven plugin, to be honest. But I would say that anything native image is still up in it. Sorry, native image for JavaFX is more working by chance than anything. So how to get it working is, someone will need to go and contribute more stuff to that JavaFX extension. But that could be an interesting episode, like stuff we don't think that works. How much is missing episode? So yes. Okay, and then see, Sabina says that he's interested in the Q&A. We should do that. So we'll do that. Yeah. And then there's a question for you, I think, Ollie.
Well, I think it's a question for both of us, actually, because I made like a bold statement, and now you can come in and then add some of the nuance. I think I remember that discussion because we were talking about, like, with everything, there's always trade-offs, right? And we work on Quarkus, we love Quarkus, and so then the question is is Quarkus good? Is Quarkus the best choice in all circumstances? And the short answer is yes, clearly. But then there's sort of a slightly longer question, which is like, okay, well, where is it stronger? Where is it less strong? And I think what I said was, because of how we do the class loading in Quarkus, at some point, if your monolith gets big enough, you're going to start to end up with conflicts on your class path, and then you end up in that sort of nasty class path situation. And so then maybe at that point, if that was your main requirement, maybe you'd start to feel some pain. And so then the follow-on question here is, can you explain that a little bit and compare to other frameworks? Do other frameworks not have a flat class path? So I don't know enough to make a general statement about the class loading of all of the frameworks. I know I, in a previous life, did work on WebSphere Liberty, which became Open Liberty. And on that one, and this is my background, because on that one we used OSGI under the covers, which allowed us to avoid a whole bunch of class loading conflicts because it was super compartmentalized. But again, it's all trade-offs.
Okay, so I'm not disagreeing with you. I would say Quarkus works perfectly fine in a monolith, especially a majestic monolith. In a good design, monolith is fine, right? But yes, if you are building stuff that requires like a lot of separate use, like, hey, I have a class loader here specific for this, or multiple version of the same jar for something, yes, then it becomes an issue for sure.
Yeah, so Quarkus isn't good for monoliths. Like, that is definitely way too broad a statement. That is not true. As Mike said, it works really well for monoliths. That is a nice use case for Quarkus. If you discover that you have all of Maven Central in your POM file, then maybe at that point, maybe you want to think about that. I mean, but if you have all of Maven Central in your POM file, like, you want to think about that anyway, no matter what framework you're using, because it's gonna hurt you.
Yeah. And then Sander, for example, is saying here, like Sander, who works for Ahead, by the way, but he says Wildfire has excellent modularity features organized in isolated class loaders. And that's what the app server is good at. I know he's talking about a level that's even further below that you can do other kind of things. But yes, that is not. Quarkus has kind of taken a stance of you run smaller things together, and if you want to really do multiple separate things, you'll have them as different separate services. So yeah, there are different choices, different things there. But yeah, so I don't know if it's if you have a big monolith with a lot of different things in it, sure, Quark is probably not the biggest solution, but I doubt that's going to be. There's no framework that's going to be good at that. Then you'll have to do stuff like Wildfly's module systems or OSGI or something else to get that.
Yeah, and that's just a reflection of how we write applications these days, really. Is the requirement for applications used to be, can I have a single instance of my application server, and can I put my entire estate into that single instance of the application server? And now we're like, well, it's so the application server or framework is so small. Why wouldn't you have multiple processes? Because that gives you other benefits.
Yeah, exactly. So no, but yeah, we should have fun to have a Q&A session.
We've got one last compliment too.
Yeah.
Thank you. Thanks, Douglas.
Good. Yeah, and just by one thing, just to it's not because we want to be complicated to use for complex monoliths. It's just that it's simpler to deal with, like native image, where you want to have a closed scope, and it's just lots of details that is there. What is he saying? I got Quarkus run as a Windows server using Java FFM to call Windows. You are a brave man, Douglas.
Respect.
Yeah. And Sanna is saying we are working hard on dependency alignment between extensions. So it's very unlikely in practice. Yes, that is the goal, but it's also the bane of my existing, or sorry, my struggle these days, because there are things that are coming up. Like everyone says, hey, we want to have the latest, greatest new Java JDK. And the Java JDK is also being modern and removing things. Like the security manager is coming in Java 23. Or Oracle saying, hey, we want to rename JavaX to something else, Jakarta EE. And suddenly we have this staggering of stuff that we would like to upgrade, but not all extensions or dependencies are aligned. What do you do? Yeah, we did the Java EE, was that like last year? Yes, I guess that was last year. And now in Java 23, I just know, for example, the security manager is going to go away, and I know there is some other dependencies that doesn't like that.
That's the Quarkus philosophy, really, is that Mac suffers so that you don't have to.
There's a lot of people that suffer on this one, yeah. But this is that's what we're trying to do. And remember, the good thing is we say, well, okay, you can't get everything to work in the same JDK or JVM, but then you can have two JVMs or two native images, and they talk together, and you're fine. So yeah. I want to say far more efficient than Spring Boot, says Douglas. Our team uses it for models as well, no issues. Good. It's perfect.
Yeah. And, as Max says, that's exactly what the platform's for. And that's kind of why we have this idea of the Quarkus platform, is so that you get this set of extensions that are tested together, that we all know work together, that are a sensible combination, that are going to do what you need to do without you getting into dependency hell.
And you can, of course, always try and add some stuff in, and you'll, in any case, be fine. And I want to remind people, those frameworks that has the ultimate flexibility, you're on your own when you start, like that problem doesn't go away just because your framework allows the dynamic stuff. Like you still have to figure out, oh, this version works with this version. We're trying to make it, hey, there's at least one version that we know and support, and that stuff is there. And that's oh yeah, you just showed it.
Yeah.
Great. So so no. Okay. And what says Sapenda says these Quarkus Insights continues forever. They're great. Yeah.
Oh, yay.
Thank you. Good. You don't hear that often, so please keep coming. That's good. So no. Anyway, I think we got through the questions, and yeah. And
we should thank Christian as well. Yeah, super interesting.
He was saying he'll be done in 50 minutes. And,
actually, I have one more. I have one more thing. This is like 10 conversations back, but when you were talking about the pros and cons, which I really liked, Christian, and the data cleaning, I saw a really good talk at Vox Zurich, and he was talking about vector search and the calculating the embeddings and that kind of thing. And one of the things that his demos that he had was doing an image analysis to see if it had to identify a Pokemon character in the image. And it worked really well until he pointed out that what it was actually doing was looking for yellow. And so if he had a Pokemon against a yellow background, it would always say it was the yellow one. Is it Pikachu? Anyway, so it was
right. Yeah, you
have
to
visual
test
example of the kinds of problems that you can get.
Yeah. No. Yeah. Computers are perfect. Or probably not perfect. They're like humans now. Good. They can be wrong. No. Cool. Anyway, thank you, Christian, and thanks for all the the questions here. And yeah,